Welcome to part two of lesson four, the division of labor. Adam Smith, in his seminal work, An Inquiry into the Nature and Causes of the Wealth of Nations, presented the division of labor as a fundamental driver of economic progress and productivity. He argued that by breaking down production processes into specialized subtasks, workers could develop greater dexterity, save time that would otherwise be lost in switching tasks, and foster innovation in tools and methods. This specialization transforms inefficient individual effort into highly efficient collective output, acting as a dynamic engine of economic progress. Find the year that The Wealth of Nations was published and enter it there. A classic illustration is Smith's Gloucester pin factory example. He chose pins for this example because they were essential everyday items used in clothing, sewing, tailoring, embroidery, and household fastening. In a small manufactory with rudimentary machinery, the process of making pins involved 18 specialized tasks, which are listed here. Adam Smith's observation of pin making vividly illustrated the power of the division of labor. When tasks were undivided, a single worker performing all 18 steps produced only about 20 pins per day. In small workshops with partial division of labor, where 8 to 10 workers shared the 18 tasks, each worker could produce around 800 pins per day. In a large-scale factory with optimized division of labor, each worker's output surged to 4,800 pins per day. Play and pause the following video to help you solve your version of this problem. Compute all numerical answers using unrouted numerical inputs. When entering your answers into the answer boxes below, record your answers in 2 decimal places. Use the above information to answer the following questions. In a workshop of 10 pin makers with no division of labor, each worker would need to perform all 18 tasks, producing only 20 pins per day. The total daily output of the workshop would therefore be just 200 pins per day. However, if these same workers specialized in one or more of the 18 tasks, productivity would rise dramatically to, here it says, in small workshops with partial division of labor, where 8 to 10 workers shared the 18 tasks, each worker could produce around 800 pins per day. So this would be 800. And that would raise total output of the workshop to 8,000 because we have 10 workers in the workshop. This marks a blank fold increase in per worker productivity. Well, we're going to divide the 80 by the 20. To calculate that, we're going to divide the 800 by 20. And 800 divided by 20 is 80 divided by 2. And 80 divided by 2 is 40. So it's a 40-fold increase in productivity, which is how much in percentage terms? Well, to get that, we're going to come down here and calculate it. After division of labor in the small workshop, output per worker was 800. Before that, before the division of labor, was 20. So it is 800. It was 20. Is minus was divided by was multiplied by 100 to turn it into a percentage gives a percent increase of 3,900. That's a massive increase in productivity. Now, Smith attributed these gains to what? Enhanced skill and efficiency, time savings, innovation, and scalability. Adam Smith acknowledged limitations to the benefits of the division of labor, noting that it was constrained by market size and could result in worker monotony due to repetitive tasks. Nevertheless, the division of labor significantly boosted wealth creation by transforming manufacturing from home-based production, known as the cottage industry, into large-scale factories where numerous workers performed specialized repetitive tasks. Before factories dominated, making straight pins was a domestic system in which families produced pins at home under the putting out system. Most of the workers were grandmothers, wives, and daughters. They performed this work outside their normal household chores in their spare time. Because merchants supplied all raw materials, they had no expenses, and their earnings from this effort came entirely from the number of pins they produced. Merchants delivered raw materials, purchased finished pins, and coordinated the logistics, transporting materials to workers and collecting finished goods, allowing workers to focus solely on production and maximizing merchant profits. Output was only about 20 pins per day when each worker performed all 18 tasks in their homes. Assume that labor costs account for 31% of pin sales, raw materials for 38%, distribution materials to workers' homes for 2.5%, collection of finished pins for 2.5%, and the merchant's profit margin for 26%. Merchants sell 497 papers of pins per month, with each paper containing 100 pins. At a price of 36 pence per paper of pins, using these figures, complete the table below, with 240 pence equal to £1 sterling. I'm going to use this spreadsheet to help me answer this question. So price per 100 pins is 36 pence. Since we're selling 100 pins together, 36 pence per paper of pins, which contains 100 pins. That'd be like a 6-pack of Coca-Cola. Each pin would be 0.36 pence per pin. Convert the pence to pounds. So you do that by dividing the 0.36 by 240. And so each pin is 0.0015 pounds sterling per pin. Merchants sell 497 papers of pins per month, and there's 100 pins in each paper. We'll multiply this by 100, and that's pins per month. These are going to be the percentages of the price. Labor, in my model, is 31% of the pin price. So I'm going to type this as 31%. Raw materials is 38%. Distributing materials to workers' homes is 2.5%. Collecting finished pins is 2.5%. And the merchant's profit margin is 26%. And then this should add up to 100%, which it does right there, see? This first answer box is pence per paper of pins. So that's equivalent to saying pence per 100 pins. That price was 36 pence. Price per pin was 0.36 pence. Price per pin in terms of pounds was 0.0015. The merchant is selling 497 pins, 497 papers of pins per month. And since there's 100 pins in a paper, the merchant is selling 49,700 pins per month. So this would be papers per month, and this would be pins per month. Both of these are quantities, right? The pence per 100 is the 31% times the price per 100 pins. I'm going to copy this down. I want to freeze the red box. So I'm going to put a $sign in front of the 1. And when I drag it down, it'll give me the portion of the price that goes to labor, raw material, distributing materials, collecting pins, and the merchant's profit. And then total sales, pence per 100 pins, is the 36. Or I could do, to check my work, I could do a sum and just highlight these numbers, and it should add up to 36, and it does. I'm going to copy these things to my table here. Press enter to make sure I got it right. Now I want to get pounds per month. I'm going to switch from pence per 100 pins to pounds sterling per month. This, taking the 11.16 and dividing by 100, that gives me pence per pin. Because remember, they're priced in packets of 100, and they call them papers of pins. I need to divide that pence by 240 to turn it into pounds sterling. Now, if I were to bring this down here and then sum it up, notice that I get the same thing as up here. See that? At this point, I just converted these from pence to pounds. It'd be like turning pennies into dollars. So this number here equals that number there. Now I want to turn it from pounds per pin to pounds per month. So this is the price of each pin, but we make that many pins in a year. So I got to multiply this by the number of pins we make in a month. Now, when I drag this down, I want to freeze this red box there. So I'm going to put a $sign in front of the 5 and then pull it down. The merchant's making total sales, not profit, total sales of 74.55 pounds sterling per month. The merchant's profit is 19.38 pounds sterling per month. Laborers collectively are making 23.11 pounds per month. And there's going to be quite a few laborers here. So labor costs a merchant 23.11 pounds per month. Buying the raw materials is 28.33 pounds per month. Distributing the raw materials to the individual houses is 1.86 pounds per month. Collecting the pins that are made by the households is 1.86 pounds per month. And then the merchant's profit, like I said, is 19.38 pounds per month. And total sales is 74.55 pounds per month. I'll press enter to make sure I got that right. Now, with the merchant buying a total of 497 papers of pins per month, this here is pins per month, not papers of pins. So we have to multiply this 497 by the 100 to get the pins per month. 497 papers. Since there are 100 pins per paper, we got to multiply by 100. Each worker is making 20 pins per day with about 26 work days in the average month. Sundays, we're assuming they're taking that off for church and stuff. The merchant was coordinating the production of how many workers on average. So this is the pins per month, 20. Typing equal B5 gives me the pins per month that the merchants buy from all the houses that they manage. If each worker is making 20 pins per day, we multiply that by 26 work days in the average month, where they're not working on Sundays. If we multiply that by 26, we get each worker making 520 pins per month. Now, this is total production of all the workers, and that is how much each worker is making per month. So if I divide the big number by this 520, I get the average number of workers that are managed by this merchant. And it's 95.58 to 2 decimal places. With each house being home to 6 workers, the merchant distributes raw materials to and picks up finished goods from an average of how many houses? In my model, there's 6 people per house. And since each worker makes 520 pins per month, and there are 6 people per house, each house makes 3,120 pins per month. If I divide total pins per month sold by the merchant by pins per house, I get the total number of houses, which is, to 2 decimal places, 15.93. Each worker is earning how much per month? Each worker is making 520 pins per month. Each worker is making 11.16 pence per 100. So we're going to divide the 520 pins per worker per month by 100. So each worker makes 5.2 papers of pins per month. We're going to multiply that by the price, the pence per 100 pins. And we get worker pay at 58.03 pence per month. If I divide that by 240, each worker is making 0.24 pounds sterling per month, per year, times 12. And I get 2.9 pounds sterling per year. And then if I multiply that by 6, I get 17.41 pounds sterling. Okay, in scenario 2, we're going to look at the putting out system with division of labor. If the 6 pin workers in each home share the 18 task of making pins, each worker could produce 800 pins a day. So instead of 20, they're able to produce 800 pins a day. Holding all other production factors constant, this is how big of an increase in the quantity supply. To get that, we're going to take the ratio of 800 divided by 20. So they can make 800 if they divide the labor up, and they can specialize in 4 or 5 tasks each. So that increases their production to 800 from 20. So it's a 40-fold increase in the quantity supplied. This 40-fold increase in the quantity supplied by each pin maker would increase the quantity brought to market to what in terms of papers of pins? When it was people doing all 18 tasks, no division of labor, papers of pins per month was 497. We're going to multiply that by 40 because it's a 40-fold increase. So the new total of papers per pins is 19,880. Now what I'm going to do is I'm going to modify this sheet here. I'm going to copy all of this. I'm going to paste it over here. I'm going to paste it as formulas. I'm going to change the color to, I don't know, green. So we have a different scenario here. Then I'm going to replace this 497 with 497 times 40. Again, it's a 40-fold increase. And so these two things are the same thing, right? Then I can delete that. With demand constant, assume this increase in the quantity of pins brought to market, which we call quantity supplied, reduces the price of pins to 18 pence per paper of pins. So the massive increase in supply from 497 to 19,880 brings the price down to 18 pence per paper of pins. In my case, 18. 18 pence per 100 pins. 18 pence per paper. Each paper again has 100 pins in it. That's why we're dividing by 100 here. This is the price per pin in pence. And then we're going to divide this by the 240 to get it in terms of pounds sterling. And then we already talked about this, right? This is the 40-fold increase from that to this. This is papers of pins per month. Remember, there's 100 pins in a paper of pins. So we multiply that by 100 to get this number. And then these haven't changed because we're holding everything constant but the division of labor. So 31% is the same as that, 38, 2.5, 2.5, 2.5, 2.5, 26, and 26. Now this number here is 31% of the 18. This is the 38% of the 18. This is the 2.5% of the 18. Again, 2.5% of the 18. And that's the 26% of the 18. So these are all in pence for 100 pins, straight pins. And then we add these up and we get 18, which is the same as that. So I'll go ahead and put those numbers into here. This is 5.58 pence per paper of pins that goes to labor. Raw materials is 6.84 pence per paper of pins. Distribution is 0.45 pence. Collecting the product is 0.45. The merchant's product is 4.68 pence per 100. And then, of course, it adds up to 18 pence per paper of pins. This is per 100 in terms of pence. This is pounds per month. This is going to be each pin, right? So the first thing we have to do, we have to change it from pence per 100 to pence per pin. And we do that by dividing by 100. And then we want to change it from pence to pounds sterling. And remember, there's 240 pence per pound sterling. So we got to divide that by 240. So this is the price per 100 pins, and it's in pence. This is the price per straight pin in terms of pounds sterling. Now all we have to do is multiply this by our output, and that's our output per month. And I'm going to freeze E5 in row 5. I'll put a dollar sign between the E and the 5, and then I'll reduce it to 2 decimal places, and then I'll drag it down. And then this right here is the total value of selling the pins, the almost 2 million pins here. The merchant's profit is that. Laborers are paid this in total. And the people who supply the raw material, they get paid that amount. And then the merchants got to pay people to distribute the raw material to the houses. They got to pay people to pick up the finished street pins from those houses. And this again is earnings per month. So I'll go ahead and put those numbers in here. Okay, now with the merchant buying a total of how many pins? The merchant is buying that many pins of paper. The merchant's buying a total of that times 100, right? Which is that amount. Now, how many workers does this merchant have working for it? Well, the pins per worker per day increased to 800. And this is per day per worker. This is per worker per month because we're multiplying the 800 times 26, correct? And this value here is the pins that are produced per month that the merchant buys from all the people working for it. and then sells it in its store. That number is from here. And notice that the number of workers, the average number of workers per merchant is still 95.58 because this times that is this number. I did find this though by doing what? Dividing this total number of pins by the pins per worker per month to get the number of workers. So the number of workers is still 95.58. Okay, so remember there are 6 people in each house. Maybe 2 female siblings, a mom, an aunt, a grandmother, and a niece. 6 women in this house making these pins. So if there are 6 workers per house, how many houses are there? Well, the pins per house, remember, is we find this number here, pins per house, by taking the pins per worker per month and multiplying by the number of people in each household on average. And that is 6. So pins per houses is 124,800. And then to find the number of houses, it's just this divided by that. If I were to multiply this times that, I would get pins per month. The number of houses hasn't changed, 15.93. Because remember, we're holding everything constant, right? Except for the division of labor. Now, the division of labor made us more productive. It increased the quantity supply of papers of pins, or pins in general, which pulled down the price. So the things that we're holding constant are these percentages here, right? Now, what does each worker make under this new system where there's specialization, a limited amount of specialization, but specialization, because different people in the house are doing different tasks of making the pin. Somebody gets really good at cutting the length of the pin from the original wire. Somebody gets really good at sharpening the thing, right? So everybody's focusing on what they do best. A comparative advantage thing that's to come with David Ricardo. Okay, now notice that the pence per 100 of pins was 11.16. Now it's 5.58. So you might think that the people are getting paid less. But what happened to productivity? It increased by a factor of 40. So the price you're getting per pin or per 100 pins about halved, but productivity increased by a factor of 40. So what we're doing now is we're multiplying this new pence per 100. Let's first do the pence per 100. Okay, this is pins per worker per month. This rate is pence per 100 pins. So we're getting paid $5.58 for every 100 pins we make, for every paper of pins we make. So we need to package these individual pins into packs of 100. So that's why we first divide it by 100 here. So this is in terms of pins. This is in terms of packs of pins. And those packs happen to be 100 pins each. So we're producing 208 packs of pins, and we're getting paid $5.58 per pack of pins. So this is how many we're making. We're going to multiply that by the 5.58. And that gives us how many pence we're making per month. So each worker earns 1160.64 pence per month. So to convert it to pounds, we divide it by 240. And we get 4.84 pounds sterling per month. But this says per year. So now this is per month. We're going to multiply it by 12 to get per year. So 58.03. So each worker is now making 58 pounds roughly per year on their pin production. That's the average worker. When every person in the household did all 18 tasks and there was no division of labor, each of them earned 2.90 pounds sterling per year. Now each person is making 58.03 pounds sterling per year. For the household, we got to multiply this by 6 because there's 6 people in the house. So household income, 348.19 pounds sterling per year. So division of labor caused household income to increase from 17.41 pounds sterling to 348.19 pounds sterling. That's a substantial increase in household income. Now we're going to do scenario 3, factories with division of labor. To eliminate the cost of distributing raw materials, so it's costly to distribute raw materials, it's costly to pick them up from people's houses. Suppose a merchant builds a large factory to consolidate pin production. And there were how many houses? There were 15.93 houses. So they got to take product, and maybe these houses are kind of spread out. So they got to take product, they got to take raw material to each of these 15.93 houses, and they got to pick up the final product, the actual pins. Instead of working from home, the workers, and there were 95.58 workers, right, on average for each merchant. The 95.58 workers are hired to work in this factory instead of out of their house. This eliminates distribution and collection cost entirely, but because workers now bear the cost of traveling to and from the factory, time being a cost, the merchant, it says, hey, we'll split the savings with them 50-50. You can think of that as this goes to labor and this goes to merchant profit. So these two things have been zeroed. So this is zero, this is zero, this is zero, and that's zero. Because this goes to labor and this goes to merchant profit. And there are 18 tasks, and they're evenly divided amongst the workers. And this allows the factory and its workers to achieve economies of scale. As a result, pin production per worker surges to Adam Smith's factory estimate of, I think it was 4,800 pins per day in the factory. The factory has all kinds of time-saving equipment. Holding all other production factors constant, this is a blank fold increase in quantity supplied from scenario 2. So from scenario 2, where each worker is making 800 pins per day, to scenario 3, where every worker is producing 4,800 pins per day, it represents a six-fold increase in the quantity supplied. So what I'm going to do now is I'm going to copy the green stuff, Control C, and right here on H1, I'm going to do Control V. I'm going to change the color to, I don't know, red. Okay, so how much does papers of pins increase by? Well, we got to multiply the old quantity brought to market of papers of pins. We're going to multiply that old one by 6, right? The old one is 19,880. The new one, six-fold increase in papers per month. And again, papers are 100 pins in a package, right? When you say papers per month, in terms of pin production, you're talking about 100 pins wrapped in one piece of paper. Output increases substantially. Let's copy this and paste it there. So with demand constant, assume this increase in quantity of pins brought to market reduces the price of pins to 24 farthings per paper of pins. 4 farthings is 1 pence. So we have to divide this by 4. We have 24 farthings here. This is 24 farthings. It's not 24 pence. To turn it into pence, we have to divide it by 4. And we get 6 pence. Now down here, we're going to zero this because this 2.5% went to labor and this 2.5% went to merchant profit. The factory owner goes, hey, if you come into the factory, I'll give you 2.5% more. So instead of 31%, you'll get 33.5%. And then the merchant keeps the rest of the 2.5%. So half of it goes there and the other half goes to here. So we're going to zero that out and we're going to zero this out. Now this has to equal 100, right? But it doesn't. It's only equaling 0.95. This 31% plus that, and we do the same thing down here for the merchant profit. So 26% plus this 2.5%. Now, when we add that up, we get 100% total. So this is 6 pence per 100. We're going to multiply that by 33.5%. So 2.01 goes to labor it was 5.58, and initially it was 11.16. So labor costs are really coming down, and you would think that the laborer is getting paid less. But again, this is about a little more than half of the 5.58, right? And this is about half of the 11.16. The increase in productivity outweighs the decrease that is paid to labor. So this right here is 2.01. Raw materials is 2.28. We've already put in the zero for distributing raw materials to houses because now it's at a factory. And then we set picking up the finished product from the houses to zero because now the finished product is already at the factory. And then the merchant's profit is 1.71. When you add this, and that together, you get a total of 6. And again, it's 6 pence per hundred. Now over here, we want convert the pence to pounds sterling. We want to convert the 2.01 from per 100 to per month. So the first thing we have to do is we have to convert this to 0.0201 pence per pin. And then we want to convert that into pounds sterling by dividing it by 240. And we end up with the price per pin equal to 0.000083750 pounds sterling per pin. Now we're going to multiply this by the pins produced per month. And when I pull this down, I want the red box to stay in row 5. So I'm going to put a dollar sign between the H and the 5. And then I'm going to reduce the number of decimal places to 2. I'm going to pull this down. And then this is the sum of those, right? So this is the total revenue, the merchant, now the factory owner. This is the factory owner's total revenue from selling this many pins per month. Some of it goes to labor. Some of it goes to purchase raw material. None of it's going to distributing the raw material to the houses because now the work is being done at the factory. None of it's going to pick up the finished product from those houses because, again, it's being done at the factory. And then this right here is the profit of the factory owner who started out as a merchant. And when you add those up, you get this number. So let me type those numbers into here. So pounds per month, raw material, merchant profit, total monthly sales. I'll press enter to make sure I got it right. And I did. In this third scenario, the red scenario, we're at a factory now. So this is now 4,800. It was 800 when there was division of labor in the houses. Now there's 100% division of labor and specialization in the factory. So productivity soars to 4,800 per worker. And then this is per day. This is per month because we're multiplying by 26 days in the month, not Sunday. So 26 on average, roughly. The number of workers is still 95.58. We haven't changed that. All we've changed is where they're doing their work. They were doing the work in the house, and then we allowed them to specialize. Those 95.58 got 40 times more productive when we allowed them to semi-specialize. And then they got ultra specialized when we went to the factory. But each scenario, each merchant had 95.58 factory workers on average. And these factory workers are making how much? This right here is the pins per worker per month, right there, right? They're getting paid 2.01 per 100 pack of pins. So we need to first divide this by 100. So this is 124,800 pins. This is 1,248 packs of pins. Now we can multiply this by the 2.01 because that's pence per pack. So this is how much they get paid per month in pence. We're going to divide that by 240 to find out how much they get paid in pounds sterling. Each month they're getting paid 10.45 pounds sterling. We're going to multiply that by 12. So this is 125.42 pounds sterling per year. Thus, each house adds 752.54 because there's 6 people that are making pins in each house that are now working at the factory, this labor collectively nets each house income of 752.54 pounds per year. Now, from scenario 1 to scenario 2, the members of each household specialized in several of the 18 tasks. In scenario 1, they each did all 18. There was no specializing. But the difference between scenario 1 and scenario 2 is the fact that the members of the household, there was some limited specialization in labor. There was some division of labor. And this resulted in what percent increase in merchants' income? Well, to get that, we have to look at this line here, merchant profit, right? I'm going to boldface that. And I'm going to type right here, equal. This is what they made in profit at the end of scenario 2. And this is what they made in profit in scenario 1. So it's is minus was divided by was times 100 to convert it into a percent. And that's 1900%. That's a huge increase. What about the worker's income? The worker's income is, I'm going to get rid of the times 6 here. So this is annual. This is annual. And that is annual. Okay, so now we're going to look at this. Bold. This is in terms of pounds per year, and pounds per year. Let me widen this up. In scenario 2, they're making 58.03 pounds per year. In scenario 1, they're making 2.90 pounds per year. So it is 58.03. It was 2.90. And then we're going to divide by what it was. And we're going to multiply that by 100 to convert it to a percent. And that's a 1900% increase. So both the merchant hiring the people to make the pins and the people making the pins both see their income grow substantially when there's a limited amount of division of labor. Now, from scenario 2 to 3, what happens? There was an increase in productivity again. That resulted in a merchant income of 849.87 in scenario 3. It was, in scenario 2, 387.66. We're going to divide that by what it was, and we're going to multiply that by 100. And now we get a 119.23% increase in merchants' income. What about worker income? The worker is now making 125.42 pounds per year. The worker was making, in scenario 2, 58.03 pounds per year. And we're going to divide that by the 58.03. We got to multiply by 100 to convert it into a percentage. So worker income increased by 116.13% from 2 to 3. Now, finally, at the end, overall from scenario 1 to scenario 3, the division of labor increased merchant income by what? Well, here, I'm going to copy this formula here, and you'll see why in a second. I'm going to paste it right there. Okay, so this is from scenario 1 to scenario 2. To get it from scenario 1 to scenario 3, I'm going to drag this to merchant profit in scenario 3. And I get a huge increase, that's a percent increase, in merchant income. What about the worker? Well, this was the percent change from scenario 1 to scenario 2. I want to do scenario 1 to scenario 3. I'm going to put that here. Actually, I'll put it here. From scenario 1 to scenario 2. From scenario 1 to scenario 3. Again, a pretty massive increase in worker income.